Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 6. Let's consider this network consisting of 7 resistors labeled R1 through R7 as well as 4 current sources IA, IB, IC and ID. The question now is to calculate the dissipated power in the 1 ohm resistor. The 1 ohm resistor is a resistor R7. Let's move on to the solution. First, let's begin by defining the number of meshes. In this network, it's evident that there are 7 meshes. This is mesh 1, mesh 2, mesh 3, mesh 4, mesh 5, mesh 6 and mesh 7. Now let's proceed to assign the mesh currents in this network, and I will consider I1 the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, I4 is the current in mesh 4, I5 is the current in mesh 5, I6 is the current in mesh 6 and I7 is the current in mesh 7. After we finish the assignment of the mesh currents, we need to remove the branch contains the current source IB. Then we obtain our supermesh. By applying KVL in the supermesh, we can write R1 I2 minus I1 plus R2 I2 plus R3 I3 minus I6 plus R4 I3 minus I4 is equal to 0. If we replace the resistors with their numerical values, we obtain 5I2 minus I1 plus 5I2 plus 8I3 minus I6 plus 4I3 minus I4 is equal to 0. If we continue simplifying this equation, we obtain 10I2 minus 5I1 plus 12I3 minus 4I3 minus 8I6 is equal to 0. And I will call this equation 1. Let's go now to mesh 2. By applying KVL in mesh 2, we can write R4 I4 minus I3 plus R5 I4 minus I6 plus R6 I4 minus I5 is equal to 0. By replacing the resistors with their numerical values, we obtain 4I4 minus I3 plus 8I4 minus I6 plus 8I4 minus I5 is equal to 0. If we continue simplifying this equation, we obtain 20I4 minus 4I3 minus 8I6 minus 8I5 is equal to 0. And I will call this equation number 2. Let's move on now to mesh 1. We can see here that I1 is equal to IA. That means I1 is equal to 3 amps. And I will call this equation 3. We go to mesh 3. In mesh 3 we have I5 is equal to negative IC. That means I5 is equal to negative 4 amps. And I will call this equation number 4. Let's move on now to mesh 4. By applying KVL in mesh 4, we can write R3 I6 minus I3 plus R7 I6 minus I7 plus R5 I6 minus I4 is equal to 0. If we replace the resistors with their numerical values, we obtain 8I6 minus I3 plus I6 minus I7 plus 8I6 minus I4 is equal to 0. If we continue simplifying this equation, we obtain 17I6 minus 8I3 minus 8I4 minus 7 is equal to 0. And I will call this equation number 5. Let's move on now to mesh 5. We can see here that I7 is equal to ID. That means I7 is equal to 2 amps. And I will call this equation number 6. We currently have 6 equations with 7 unknowns, which mean we require one additional equation to solve this problem. In order to get this equation, let's focus on the current source IB. We can write IB is equal to I2 minus I3. We already know that IB is equal to 1. That means 1 is equal to I2 minus I3, and I will call this equation 7. After we finish applying the supermesh analysis, we obtain 7 equations with 7 unknowns. We still only need to solve those equations to calculate the mesh currents. Let's start first by equation 3 and equation 7. By substituting equation 3 and 7 in equation 1, we obtain 10 multiplying 1 plus I3 minus 15 plus 12I3 minus 4I4 minus 8I6 is equal to 0. If we continue simplifying this equation, we obtain 22I3 minus 4I4 minus 8I6 is equal to 5. I will call this equation A. By substituting equation 4 in 2, we obtain 20I4 minus 4I3 minus 8I6 is equal to negative 32. And I will call this equation B. Let's move on now. By substituting equation 6 to equation 5, we obtain 17I6 minus 8I3 minus 8I4 is equal to 2. We can see here that equations A, B, and C, we have only 3 unknowns, I3, I4, and I6. Those 3 equations can be written in matrix form as follow: Ri is equal to V, where R is given with this matrix. The first column is the coefficients multiplying I3 in the first equation, second equation, and third equation. The second column are the coefficients multiplying I4 in the first equation, second equation, and third equation. And the last column are the coefficients multiplying I6 in the first equation, second equation, and third equation. I is present the vector of the unknown mesh currents, and V is given by 5, negative 32, and 2. Since this problem is quite difficult to solve, I create a MATLAB program that makes it easier, which given with this picture. If we run this program in MATLAB, we obtain the values of the current I3, I4, and I5. We know that the current I through the resistor R7 is equal to I6 minus I7 is equal to 1.2096 minus 2, we get negative 3.209 amps. The dissipated power in the resistor, in the 1 ohm resistor or resistor R7, is equal to R7 multiplying by I square. We get 1 multiplying by negative 3.2096 square, we get 10.3 watt. After completing the calculation, we conduct a simulation using a SPICE simulator to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in a SPICE simulator. We need to calculate the dissipated power in the 1 ohm resistor. I connect here a wattmeter to measure the dissipated power in the R7 resistor. Let's move on to analysis, DC analysis, calculate nodal voltage. We can see here that the dissipated power in the 1 ohm resistor is equal to 10.3 watt, is exactly the same value we have done by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email. If you like this video, subscribe and share. See you next time in another example about Supermesh analysis. Take care and bye bye.